Welcome to DC to Daylight. This is Aaron, amateur radio call sign N6ACA. Today we're going to talk about fan dipoles. So when you started in ham radio, probably your first HF antenna was a 10 meter dipole. It's pretty easy to compute the length and cut it from whatever sort of wire you had around, whether it be zip cord or something else. And so you might be thinking, well, hey, what's my second antenna? A lot of people go for the end-fed half wave, either in the 40 meter or 80 meter variety, which is an excellent antenna, which allows you to have a completely resonant match for many parts of the amateur radio bands. The problem with end-fed half waves is that they can be very noisy depending on where you're implementing them. So my choice for your second antenna would be for a fan dipole. So a fan dipole uses many of the same aspects that you use in a regular dipole antenna. You have the wire elements, you have a something to hold the center of your antenna with your feed line connector, your balun, and whatever you're going to be connecting up to the individual wire elements. Well, when you've already got that in the dipole, what you do is you connect up more wire elements at the center connection where your coax connects up. Each of those elements is going to be tuned for a frequency that you are interested in. So a common fan dipole configuration is one that has radiating elements for 40 meters and 20 meters. So what is involved there is you basically have a 40 meter wire, and then you're going to have some sort of separating spreader to make sure that you have at least 6 inches between each individual radiating element. An antenna that size is probably going to be outdoors. With a fan dipole, you can have as many elements as you would like. It has almost not exponential, but an increasing difficulty when you come to tune it when you add more elements. So two separate elements are pretty simple. 3, 4, and 5 different elements, it becomes very difficult. So generally what you're going to do is you're going to tune from the lowest frequency or longest wire down to the shortest wire and highest frequency. And when it comes to tuning, it's really helpful to use a vector network analyzer like a Nano VNA or an antenna analyzer to do a sweep on the antenna to basically let you know when you have received resonance on that band, and that's indicated by a lower standing wave ratio or SWR on that section. The benefit that you receive by having a fan dipole is there's a rejection of noise in the areas where you don't have resonance. So you do have reception capability, but in comparison to an end-fed half wave, you actually reject quite a bit more noise. And that's really helpful if you have a compromised antenna situation, so you can actually hear through the noise. What can be more difficult about a fan dipole or dipoles in general when it comes to placement at your QTH is that the feed line is in the center of the antenna versus at the end with an end-fed half wave. So it makes positioning a little bit more difficult. A fan dipole lends itself to the DI wire in that many of the items that you use to create the antenna can either be 3D printed, or you can repurpose other types of plumbing and electrical hardware to work for the spreaders and end connectors, center connectors. There's a plethora of items out on printables and other 3D printing websites that have information where you can print out those supplies. I've used PVC pipe as spreaders. I've used agricultural flexible pipe for sprinklers to spread the antenna, and that's worked well for me. As with dipoles, fan dipoles work well in rafters inside your attic or garage spaces that are elevated, as long as you don't have a radiant barrier in your attic that is metallic in nature or a metallic roof. You can actually get pretty good contacts using a fan dipole in your attic, which is HOA friendly oftentimes. When it comes to roofing materials like wooden shingles, as well as composite shingles and several types of ceramic roof tiles, they do provide a certain amount of RF attenuation, but it's sort of negligible when it comes to the balance between the signal and noise created by other antennas. If you do put one of those in your attic, you really don't want to run over 100 watts. You also need to look at what type of metal ductwork or other electrical alarm and low voltage wiring is in your attic, because you might need to look at using some sort of clip-on ferrite bead connectors that include toroids to help get rid of the common mode current that may exist. And as always, when you're installing an antenna, you should do an RF exposure calculation. The ARRL has a great resource online to allow you to run through the frequency, duty cycle, and a bunch of other stuff on your transmissions to make sure that whatever you're doing is safe. But generally, if you're running QRP, so like 5 watts, 10 watts or below, as long as you're a few feet away, it's actually pretty safe. When it's 100 watts, depending on the frequency, it might be different. So just make sure that you don't have humans or pets near the antennas based on those calculations. In my own experience, I've built several fan dipoles. The current one that I am using is tuned for 12 meters, 15 meters, and 17 meters, and it works really well. It will tune to 10 meters as well as to 20 meters on my Xiegu G90 without too much trouble. But it fits perfectly in my rafters without curving, which is really great in my mind. I've found with dipoles, when they are not straight, they still work, but their patterns are somewhat skewed. And in some cases, any antenna is better than no antenna. But as much as you can do to make that pattern strong and somewhat uniform, it's very helpful. Tuning will never be perfect. When you're starting out, try keeping it under 2-to-1 SWR. Tuning will vary based on items that are around your antenna. Like I said, internal to your housing structure if you have metal ductwork, external to your house if it's near rain gutters or other metallic objects. But try your best and don't beat yourself up if you're not getting a 1-to-1 SWR or 1.5-to-1 SWR. This has been Aaron, amateur radio call sign N6ACA. Thanks again for listening. I'll see you next time. 73.